Hello, everyone. Welcome back again, Smart Society and AI. And as you know, this is now chapter 12. So, how to show it? So, chapter 12 and the second part of chapter 12. So, we have to move to new ways. Let's see that. New ways. We finished with implementing portable patient monitoring, and now we continue with completing analysis in new ways. So that's our task. Let's see what we have. So using AI in a manner that best suits its capabilities maximizes the potential for medical specialists to use it in a meaningful way. Data analysis is one area in which AI excels. We just mentioned it. In fact, entire websites are devoted to the role that AI plays in modern medicine as well. Merely taking a picture for a potential tumor site and then viewing the result might seem to be all that a specialist need to make an accurate diagnosis. However, most techniques for acquiring the required snapshot rely on going through tissue that isn't part of the tumor site, thereby obscuring the output itself. In addition, physicians want to obtain the best information possible when viewing the tumor in its smallest stages. Using AI to help perform the diagnosis not only assists in identifying tumors when they are small and with greater accuracy, but also speeds up the analysis process immensely. Time is critical when dealing with many diseases. So, as impressive as the detection and speed capabilities of AI are in this area, what truly makes a difference is the capability to combine AI in various ways to perform IoT, so Internet of Things, data compilations. When the AI detects a condition in a particular patient, it can automatically check the patient's records and display the relevant information on screen with the diagnosis scans. Now the doctor has every last piece of pertinent information for a patient before making a diagnosis and considering a particular path. We can continue with the so-called telepresence. In the future, you may be also able to call a doctor to help with a problem and not even visit a hospital or clinic to do that. For that matter, you may be able to call on just about any other professional in the same way. The use of telepresence in all sorts of fields will likely increase as the availability of professionals in specific areas decreases due to continuing specialization. So the term telepresence simply means to be in one place and seems as though you are in another. Let's see a video about it.
There's a lot to be desired when it comes to video conferencing, and there's so much more that we could be doing when it comes to having virtual meetings. And that's really ultimately the promise of what's called telepresence. This is a term that was coined back in the 1980s by an important computer scientist named Marvin Minsky. Essentially, telepresence gives the effect of being at a place other than your own location. So imagine that you could present yourself as some sort of hologram where you enter a real physical space somewhere else in the world and feel as though you're there, and people who are at that real place perceive you as being there, or at least perceive your hologram as being there, and can interact with you as you would in a real physical meeting. That is the end game of telepresence. It ultimately gives you the effect of being at a place other than your true location. The key thing that classifies telepresence as an experience is that the user is virtually interacting with a live, real place. Virtual reality, or VR, is different than this because the user is being given an artificial environment to quote-unquote enter. And it's also different than augmented reality, or AR, where the user is given the illusion of content being added to the physical space immediately surrounding them. You can think of telepresence as replicated reality. Let me explain it to you in terms of movies. Alright, so for virtual reality, think Ready Player One, where a user is entering the Oasis. For augmented reality, think of Minority Report, where Tom Cruise is playing with that interface in the air. That's augmented reality. And for telepresence, think Avatar, where he's jumping in this chamber and physically controlling a real-life body. Telepresence as an idea has been around for a while, and one of the first real telepresence systems was way back in 1992. I mean, this is before Windows 95 was even out. It was the Virtual Fixtures platform, developed at the U.S. Air Force's Armstrong Labs. The system included a stereoscopic image display from the remote environment, as well as immersive touch feedback using a full upper body exoskeleton. That's one way of doing it, and the thing is, there's many different ways you can do it, and it really just comes down to the standard you're willing to accept when it comes to using this technology. I mean, when you get right down to it, technically a telephone provides telepresence because you can talk to someone in a remote location as if they were in the same room. Even a telegraph, in a way, is telepresence, but I mean, we got to have a standard somewhere. These days, a Zoom call passes for telepresence, but I think you at least need your entire field of view taken up by visual cues from the remote location, and ideally with the visual content being rendered based on your head movement. Think about Paul McCartney doing a concert. He did a concert a few years back where he had a 360 camera on stage, and users could throw on a VR headset at home and look around as if they were on stage at the concert. That was really a one-way example, though, because Paul McCartney could not see the user or in any way be affected by the user. He was just seeing a 360 camera. True telepresence consists of many pieces of information coming from you yourself, including your movements, actions, your voice, etc. It's all being transmitted and duplicated at the remote location. So many different ways of doing this. You could have a robot replicating movements. There's also a concept known as haptic teleoperation, where you could quote-unquote feel some approximation of the texture, weight, or size of some remote object. And I think that is super cool. I mean, just think about doing this on a different planet, where you could be here on Earth, picking up a rock on Mars and feeling it. And there's so many different uses of this technology. Mining, bomb disposal, rescue missions, deep sea exploration, even hostage situations. A big one is remote surgery. Think about a soldier who's wounded on the battlefield being able to get assistance from the best surgeon in the world remotely. And I'm not talking about you prop up a laptop and you have a Zoom call with them. No, I'm talking about the surgeon is actually controlling some sort of robot that is mimicking his movements. Anyway, we have a long way to go with this technology, and I can't wait till you'll be able to join other holograms in some kind of hologram meeting, because I think it'll be so cool. And I think this is actually the fundamental idea of what what Meta calls the metaverse. The ability to connect to others virtually in a very immersive way, I think, is actually a good idea. And so to Mark Zuckerberg, I say good luck. Thanks.
Hope you can hear me now. Thanks for watching one more time. So let's continue. So augmented or virtual reality exists essentially in artificial worlds. Telepresence in the real telepresence exists in the real world. Now, for example, using telepresence, you might be able to see the Grand Canyon more or less directly without actually being there. The thing that separates telepresence from simply using a camera is that through the use of the sensors, a person experiences telepresence through their own senses. It's almost, but not quite, the same as being there in person. When a person is also able to interact with the other environment, perhaps through a robot-like device, many people call it teleoperation. This is a gray area, exists in this case because it's hard to tell in many cases precisely where telepresence ends and teleoperation begins. Now, teleoperation means controlling a machine or robot from a distance, and a person sends commands to the robot using a computer joystick or other devices, and the robot carries out them in real time. Well, it's often used in healthcare, remote surgery, then space exploration, as you see here, controlling rovers and hazardous environments. So basically, like after a nuclear disaster or bomb disposal, or after an explosion, or even an underwater exploration. It allows humans to stay safe while performing tasks in dangerous or far away places. Now, one of the most common uses of telepresence is to reduce costs in hospitals in various ways. Yeah, so for example, a robot might monitor a patient in ways that monitoring equipment cannot do, and then alert either a nurse or doctor to changes in a patient's condition that the robot isn't designed to handle. Telepresence means being able to monitor patients from essentially anywhere, especially in their homes, making nursing home stays less likely. In addition, telepresence allows a patient to visit with family when such visits wouldn't be possible for any of a number of reasons. Telepresence is also making an appearance in factories and office buildings. So a security guard is safer in a secured room than walking the rounds. And using a telepresence robot allows the guard to patrol the premises without getting tired. In addition, it's possible to fit a robot with special vision to see things as a human guard can't see. Enforced use of telepresence will likely increase its use and provide an incentive to improve technology. During the COVID-19 pandemic, many doctors also began to rely on telepresence to maintain contact with their patients. And the National Institutes of Health, so NIH, also recommended using telepresence for patient-based teaching during the pandemic was also a problem for many people, especially the older population. So all these pandemic enhanced uses of telepresence will likely make the technology more common and potentially reduce its cost due to economies of scale. So once again, telepresence robots in business meetings can also possible later on using screens, microphones, and cameras, allowing remote employees attend the meeting if they are not able to be there at the site. Then remote medical consultation, the doctor can diagnose and advise a patient via video call, and remote monitoring as well. Virtual field trips, so students can visit a historical site, museum, using VR, or AR, augmented reality, or virtual reality. Remote museum tours, visitors who can't travel can control a robot that moves through the museum, and remote elder care. So family members or caregivers can use telepresence robot to check on elderly relatives, talk to them, and ensure they are safe, all from a different location. There are certain limitations as well. So the problem with telepresence is that humans can quickly become too comfortable using it. For example, many people criticize a doctor who used telepresence rather than a personal visit to deliver devastating news to a family. And in some cases, personalized human touch and interaction is an essential component of life. Telepresence also cannot replace human presence in some situations requiring senses that these devices cannot currently offer. For example, if the task requires a sense of smell, telepresence cannot support the needs at all. So given how often this sense of smell becomes an essential part of performing a task, even in a hospital, over-reliance on telepresence can become a disaster. So negative. Don't be too reliant on them. So don't depend on them. That's what it says. Okay, devising new surgery techniques is our next topic. So recently, some surgeries wouldn't be nearly impossible without the use of robots. So robots and AI now routinely participate in surgical processes. In fact, some surgeries would be nearly impossible if there were no robots or AI. However, the history of using this technology isn't long at all. The first surgical robot, Artrobot, made its appearance in 1983. Even though the use of these life-saving technologies has reduced errors, improved results, decreased healing time, and generally made surgery less expensive over the long run. So now we continue with making surgical suggestions. So you can view the whole idea of surgical suggestions in many different ways. For example, an AI might analyze all the data about a patient and provide the surgeon with suggestions about the best approaches to take based on that individual patient's record. The surgeon could decide on the approach, but it would take longer and might be subject to errors that the AI won't make. The AI doesn't grow tired or overlook things. Unfortunately, even with an AI assistant, surprises still can happen during surgery, which is where the next level of suggestion comes into play. The patient receives the benefit of what amounts to a second opinion to handle unforeseen complications during surgery. Remember, the device isn't actually doing anything more than making already existing research, which was created by other doctors, readily available in response to surgeon requests. No real thinking is involved, and therefore preparing for surgery also means analyzing all those scans that doctors insist on ordering. Speed is an advantage that AI has over radiologists as well. Products such as Analytic, a deep learning technology, can analyze radiological scans in milliseconds, so up to 10,000 times faster than a radiologist would do. In addition, the system is 50% better at classifying tumors and has a lower false negative, so 0% versus 7% than humans. So most robotic help for surgeons today assists rather than replaces the surgeon. The first robot surgeon, the Puma system, appeared in 1986. It performed an extremely delicate neurosurgical biopsy, which is non-laparoscopic type of surgery. Laparoscopic surgery is minimally invasive, with one or more small holes serving to provide access to an organ, such as a gallbladder, for removal or repair. So the first robots weren't adept enough to perform this kind of task. By 2000, the Da Vinci surgical system provided the ability to perform robotic laparoscopic surgery using a 3D optical system. The surgeon directs the robot's movements, but the robot performs the actual surgery. The surgeon watches a high-definition display during the surgery and can see the operation better than being in the room performing the task personally. The system also uses smaller holes than a surgeon would ever do, reducing the risk of infection. The most important aspect of the Da Vinci surgical system, though, is that the setup augments the surgeon's native capabilities. For example, if the surgeon shakes a bit during part of the process, the system removes this kind of shake. Similarly to how anti-shake features work with a camera. The system also smooths out external vibration. The system's setup also enables the surgeon to perform extremely fine movements. So the Da Vinci system is a complex and extremely flexible device. The FDA has approved it for both pediatric and adult surgeries, such as urological surgeries, general laparoscopic surgeries, general non-cardiovascular, thoracoscopic surgeries, and thoracoscopically assisted cardiotomy procedures. The point behind including all these medical jargon is that the Da Vinci surgical system can perform many tasks without involving a surgeon directly. At some point, robot surgeons will become more autonomous, keeping humans even farther away from the patient during the surgery. In the future, no one will actually enter the clean room with the patient, thereby reducing the chances of infection to nearly zero. Let's continue again. So AI is great at automation. It never deviates from the procedure and never grows tired and never makes mistakes as long as the initial procedure is correct. Unlike humans, AI never needs a vacation or a break time or even an 8-hour day. Consequently, the same AI that interacts with a patient for breakfast will do also the lunch and dinner as well. AI has some significant advantages if used solely on the basis of consistency, accuracy, longevity, and then the following section we will deal with working with medical records as well. And let's see what else we have here. Oops, sorry. So one major way in which an AI has in medicine is with medical records. In the past, everyone used paper records or, like overhead this foil records to store patient's data. Each patient might also have a blackboard that medical personnel use to record information daily during hospital stay. Various charts contain patient data, and doctor might also have notes. Storing all these sources of information in so many different places made it hard to keep track of the patient in any significant way, and it was also redundant. Now it's in one single place, and using an AI along with computer database helps make information accessible, consistent, and reliable. And through that this data is centrally stored, AI can also access this data from everywhere. Obviously, important fact is that we have to save or address the privacy issues as well, so that this kind of data should never ever leave the hospital itself or the database. And only certain persons should have certain level of degree of access to this kind of data as well. Medicine is about the team approach with many people varying specialties working together. And however, anyone who watches the process for a while soon realizes that various specialists don't always communicate among themselves sufficiently, because they are all quite busy treating patients. Products such as Cloud Medex then take all the input from all the parties involved and perform risk analysis on it. The result of is that the software can help locate potentially problematic areas that could reduce the likelihood of a good patient outcome. Also, products such as DeepMind, a part of Google Health, enable personnel to mine the patient's information to see patterns in data that aren't obvious at all. So, some truly amazing predictive software based on medical records include Autonomous Health, which uses algorithms to determine the likelihood of the patient's need for readmission to the hospital after a stay. By performing this task, hospital staff can review reasons for potential readmission and address them before the patient leaves the hospital, making readmission less likely. Along with the strategy, let's say the Anju software helps doctors evaluate various therapies and choose those most likely to result in positive outcome as well. In some respect, your genetics form a map of what will happen to you in the future. Consequently, knowing about your genetics can increase your understanding of your strengths and weaknesses, helping you to live a better life. Doctors need lots of data to make good decisions. However, data being spread out all over the place, doctors have who lack the ability to analyze that disparate data quickly often make imperfect decisions. To make procedures safer, a doctor needs not only access to the data, but also some means of organizing and analyzing it in a manner reflecting the doctor's specialty. Doctors also have trouble obtaining necessary information because the machines they use tend to be expensive and huge. Okay. Yeah, and an innovator named Jonathan Rothberg decided to change all that by using a butterfly network. Imagine an iPhone-sized device that can perform both an MRI and an ultrasound. So, like that. Now, everyone complains about the price of medications today. Yes, medications can do amazing things for people, but they cost so much that some people end up mortgaging homes to obtain them. Part of the problem is that testing takes a lot of time. Performing a tissue analysis to observe the effects of a new drug can take up to a year. Fortunately, products such as Strateus can greatly reduce the time required to obtain the same tissue analysis to as little as 1 day. So better still would be for the drug company to have a better idea of which drugs are likely to work and which aren't before investing any money in the research. Drug companies also produce a huge number of drugs. The reason for this impressive productivity, besides profitability, is that every person is just a little different. A drug that performs well and produces no side effects on one person might not perform well for all, or might not perform well at all for another person and could even do harm. So Turbine enables drug companies to perform drug simulations so that the drug companies can locate the drugs most likely to work with a particular person's body. Turbine's currently emphasizes is on cancer treatments, but it's easy to see how the same approach could work in many other areas. And some companies have yet to realize their potential, but they're likely to do so eventually. Oh yeah, let's talk about combining robots and medical professionals. So semi-autonomous robots with limited capabilities are starting to become integrated into society. Japan has used these robots for a while now. The robots are also appearing in the States in the form of Rudy. And in most cases, these robots can perform simple tasks, such as reminding people to take medications and playing simple games without much in the way of intervention. However, when needed, a doctor or another medical professional can take control of the robot from a remote location and perform more advanced tasks by way of the robot. Using this approach means that the person obtains instant help when necessary, reducing the potential for harm to the patient and keeping costs low. So, considering disruption AI causes for medical professionals, well, as you can see, integrating AI into medical practices is extremely valuable. It saves time, cost, and it helps to have a perfect diagnosis. However, it's not without challenges and disruptions, both positive and negative, for medical professionals themselves as well. Here are three to consider. One of them is change in clinical roles and responsibilities. AI's ability to automate diagnostic processes and analyze vast amounts of medical data can shift the traditional roles of medical professionals. Though AI can enhance diagnostic accuracy and treatment plans, it necessitates changing how physicians and other healthcare providers approach their roles, moving toward a new collaborative model with AI system. Training and adaptation. Integrating AI into healthcare requires medical professionals to acquire new skills related to AI technologies. This includes understanding how AI tools work, interpreting AI-generated insights, and integrating these into clinical decision-making. The need for ongoing education and training to keep up with rapidly evolving AI technologies can be significant disruption and a significant burden on doctors as well. Patient-physician relationship. The introduction of AI into patient care can impact the patient-physician relationship as well, though AI can free up the time for physicians to focus more on patient interaction by automating administrative tasks. There's a concern that an over-reliance on AI could depersonalize the care itself. Ensuring that AI enhances rather than detracts from the human aspect of the care is a critical challenge. And here we go. We actually just finished our issues about the medical needs of AI. So let's look at it once again very quickly, what we have just done. So from the very beginning, you see here implementing portable patient monitoring devices, then here again, completing analysis in new ways, relying on telepresence. We talked about telepresence, and not only telepresence, but teleoperations as well. So new ways, and then we also talked about it. The three issues of disruptions, which is caused by AI inside medical issues and healthcare systems. Well, I would like to say thank you very much for staying with me and listening to the presentation itself. So I say now goodbye.